My name is Ernesto Alfaro Moreno, and I am the group leader of nanosafety at INL. Nanosafety Group was created 2 years ago under the support of the European Commission with a grant called SiNfONiA. During the first 2 years of this project, we dedicated a great effort in hiring 5 highly competent researchers to develop 5 different research lines, namely organ on a chip, epigenetics and bridging in vitro in vivo models, nanotoxicology, immunotoxicology, and in silico tools using QSAR, QSPR, and QSTR and artificial intelligence. During these 2 years, we have been working hardly in developing all these efforts, and soon we will be able to deliver the first original data coming out of these different research lines. And I would like to introduce to you my team, 5 highly competent researchers that are leading these different lines.
I'm Ana Ribeiro. I'm staff researcher of Nanosafety Group, working on SiNfONiA project, developing organ-on-a-chip systems for safety assessment of nanomaterials. Organ-on-a-chip systems has been used in drug toxicity studies, and they are helping researchers to reduce the number of animal models in research. What we try to do in a chip is that we try to recapitulate organ features and then try to understand the effect of nanomaterials on these models. In the SiNfONiA project, I started by creating a skin-on-a-chip model because skin is the biggest organ of our human body, daily exposed to nanomaterials through the use of cosmetics, through the use of novel nanotextiles, topical medication, as well as tattoos.
Hi, I'm Nivedita Chatterjee, working as staff researcher under SiNfONiA project in Nanosafety Group at INL. In Nanosafety, we have several expertise and sections, and molecular toxicology is one of them, and I am part of that. Under SiNfONiA, my role is to evaluate the underlying mechanism of adverse outcome of nanomaterial exposure, in particular genetic and epigenetic assessment after nanomaterial exposure. Damaged DNA and unrepaired or defectively repaired DNA or epigenetic modifications are known to be closely related with various adverse outcome pathological conditions, including cancer. In some cases, epigenetic modifications even known to be transferred to next generations. So it is important to include these two assays and these two endpoints in our chemical risk assessment. Here, we are developing and establishing various assays related to these endpoints for their specific biomarkers. For example, for DNA genotoxicity, we are targeting how the DNA repair capacity is changing along with the DNA damage response. Regarding epigenetic modifications, we are first targeting the global DNA methylation levels in vitro systems. And next, we have other plans for histone modifications. Besides these assays, we are also developing neurotoxicity and behavioral assays. For these cases, we are using our alternative in vivo model, that is a nematode C. elegans. Our main focus is to check the locomotion pattern and the neuronal degenerations of various neurons. Recently, we have made good progress in case of glutamatergic neuronal degeneration assessment. Glutamatergic neuronal degeneration is actually known to be very closely related with Alzheimer's disease progression. And after this, we have a plan in the next steps to make similar assays and assessment for other neurons like dopaminergic neurons, GABAergic neurons, etc. Thank you.
I'm Vania Vilas-Boas, and I'm a research fellow in the Nanosafety Research Group at INL under the framework of the SiNfONiA project. My task in the group is to promote the research activities of the Nanotoxicology research line, in which, besides performing the assessment of the toxicological effects of nanomaterials using conventional techniques, we also work hard to improve these methodologies using nano-enabled technologies. With this work, we expect to gain deeper insights into the mechanisms by which nanomaterials and other chemicals may cause harm to humans or the environment in order to better predict and prevent them from happening in the future.
My name is Filipa Lebre and I'm a research fellow at the Nanosafety Group under the SiNfONiA project, and I lead the Immunotoxicology branch of this group. Here at the Nanosafety Group, we want to understand the impact that nanomaterials have in human health. My research focus in specific is to evaluate the complex interaction between those materials and the immune system. And this is important to understand the immunomodulatory capacities of the particles, because they can be beneficial, like we saw recently with the development of COVID-19 vaccines, but they also can be deleterious. And this is important to clarify. And I will work transversally with all the research lines within the Nanosafety Group, incorporating immune cells on the systems that are being developed, so we can generate better models that mimic the conditions that we find in vivo.
Hi, my name is Michael Gonzalez Durruti. I am a research fellow at INL, specifically research fellow of the Nanosafety Group. As part of the SiNfONiA project, my main mission and objective is in charge of the in silico part, I mean the computational part. My work is focusing mainly in the development of computational approach for predictive purpose in the context of nanotoxicology. For the SiNfONiA project, it's expected to develop predictive tools like quantitative structured toxicity relationships in order to achieve the best descriptors that are relative to nanotoxicology behavior of different particles and nanomaterials from different nature and properties. These tools allow to explore many variety of compounds in the context of nanotechnology toward to ensure a safe use with the lowest health and environmental impact. All these procedures, all these in silico procedures are guided by the OECD principles and also include ethical concern respected to the animal use in the context of nanotoxicology. As part of the SiNfONiA project, will be expected to significantly reduce the use of animal models in toxicology in the context of nanotechnology, ensure the lowest environmental and human health impact for nanoparticles and nanomaterials from different nature and properties.